All right, welcome back to the second video of the day, folks. Doing the cosmology segment here. Lots of science stories to talk about. Going to be talking about everything from signal to noise ratio to 3C279 to time travel to the core of the Milky Way Galaxy to the Godzilla Galaxy. So lots of information to cover here. And let's get right down to it. First of all, let's talk about Ronald L. Mallet. Now, he's been studying relativity, time travel, quantum cosmology, relativistic astrophysics, and he thinks he's figured out how to time travel, folks. Are you on the edge of your seat? Check out this article. You want a do-over? This guy says he knows how to build a time machine. What say you? Please leave a comment if you would like to time travel, if you think you can time travel, if you have the key to time travel, yada, yada, yada. I have no comment. Let's talk about somebody who definitely knows the distinction between his you-know-what and a hole in the ground. Dr. Robitaille. Now, Sky Scholars released a new video here about the very famous black hole image of 2019, considered the greatest scientific breakthrough by the journal Science. And yeah, let me just read you the title of the image. The Black Hole Image, Data Fabrication Masterclass. So here's the image that they get, and let's talk about signal-to-noise ratio, as Dr. Robitaille, being an MRI radiologist, is all too familiar with signal-to-noise ratio. That's what the image looks like. It's a 7,416 by 4,320 pixel image. And here's what it would be with the actual signal-to-noise ratio. It would be 6 pixels. So anyway, watch the Sky Scholar video. We've linked it below the video. Let's talk about NGC 6240, which is a massive galaxy, really consisting of 2 massive radio sources. And, oh, I'm sorry, we're looking at an artist rendition here. Here are the real images of it. And what you've got here is you've got 2 massive radio sources here that are connected by some sort of a giant filament, where plasma is oriented to a magnetic field. And since gravity can't seem to explain it, and neither can dark matter, it's yet another thing on the list of conundrums. Massive Galaxy 6240, as photographed by the ALMA radio telescope series. And so another interesting article featuring a merger of 2 massive radio sources, kicking up quite a disturbance, and it'll probably be all over the news for quite a while here. Let me just read a little quote about the state of cosmology and astronomy today. Now, they think they can calculate the mass of it, but let's just read some assumptions. The mass is significant, and therefore we now estimate the black hole masses to be lower, around a few 100 million times the mass of our Sun, instead of 1 billion times the mass of our Sun. Based on this, we think that most previous black hole measurements in systems like this could be off by, wait for it, could be off by 5 to 90%. How's that for a signal-to-noise ratio? The calculation of the mass of massive radio sources, folks. Astronomers believe they know the mass of the Earth, the Sun, the Moon, Jupiter, and so on. And not only that, they think they know the mass of NGC, whatever it is, 6240. It's quite cute. And let's just leave it at that. Let's talk about fast radio bursts. This one was called 180916, and it's only the second repeating radio burst ever measured or ever determined a source of. So another interesting article here about some cosmology kicking off, fast radio bursts. 1809116J0158 plus 65 is another source of general confusion in the world of astronomy, as it's not evident how these fast radio bursts are generated. It seems to me that there are all kinds of different structures that would be able to generate radio bursts, especially considering we see radio signals coming out of the sun regularly. So anyway, we've linked to the article from phys.org also to let you know about the nearby galaxy fast radio bursts. Again, it's only the second one ever to be traced to a point source. So perhaps have yourself a read on that. This data coming in from the, I don't remember, radio telescopes. Anyway, fast radio bursts are another conundrum in cosmology. This particular burst existed at a radically different environment from previous studies, as the first repeating burst was discovered in a tiny dwarf galaxy that contained metals. And just so you know, folks, when we say metals in cosmology, we're talking about everything higher on the periodic higher on the periodic chart than helium. Everything higher on the periodic chart than helium is considered metals in cosmology/astronomy. Are you ready for the 4C405 shirt depicting the radio image of massive radio galaxy Cygnus A? Well, it's coming. By the way, this is what Cygnus A looks like in a composite image. This includes radio, visible, and X-ray. So the X-ray appears blue on this image. The visible is right there. That's just the visible light. That's a Hubble Space Telescope image. And then there's the composite, once again. Radio depicted in red-pink, X-ray depicted in blue, and visible depicted right there. A great demonstration of how all is not obvious when looking at massive radio sources. Let's talk about the Godzilla Galaxy. Another conundrum. It doesn't appear to have an active galactic nucleus. However, it's a fairly big galaxy. It's about 2.5 times the diameter of the Milky Way, but it has about 10 times as many stars. Now, this bright region that you see here in the left, just ignore that. That's a foreground star. I got to learn how to speak English today, folks. That's a foreground star in the Milky Way Galaxy there. So another interesting article here on cosmology, as these things are coming out too quick to get to, folks. UGC 2885, located about half the distance from here to Cygnus A at 232 million light years. Again, 2.5 times the diameter of the Milky Way, but 10 times as many stars. So perhaps have yourself a read. Here, I'll scroll down for your YouTube viewers if you want to hit pause and read the article. I'll wait. Anyway, the galaxy is named for Vera Rubin. It's known as Rubin's Galaxy. And Ms. Rubin, before passing away in, I believe, 2016, spent way too long searching for dark matter. Sadly, she didn't find any. But, hey, science has got to advance, right, folks? Anyway, it appears to be quiescent in terms of its galactic core, as we don't see anything too crazy going on in the center of that galaxy. No jets, no giant radio source in there that we see, as it appears to be in a quiescent state. So if you want to read about that, we did put links below the video. Let's go a little closer to home, the Milky Way Galaxy. Here it is in this stunning infrared image. Let's look at the very center here. There you have the center of the Milky Way Galaxy in infrared. And quite interesting, all the behavior going on in there. So there's the full image of that. Infrared measuring infrared radiation here, folks. And you see evidence of various different types of structures here, looking filamentary in nature. We won't dwell on it too long. Here's the article about it. This one coming out just yesterday from Sophia. And we've linked to Universe Today's article. Shout out to Universe Today! And yeah, the SOFIA stands for the Stratospheric Observatory for Infrared Astronomy. And the nice thing about infrared, folks, is that we can see through a lot of the dust to look at infrared images. And so all that dust that's obscuring the core of the Milky Way Galaxy can be seen through to a greater extent using the infrared arrays. So yet another image of Sagittarius A star, and there's the close-up of the massive radio source we call Sagittarius A star at the center of our own galaxy. Let's get even closer to home. Here's what's going on in the solar system. There's where things will be in 1 week. Here's your star chart, and it's currently 8:45 a.m. where I am. And we've got a bunch of stuff going on in the sky. We've got Mars up there, we've got Jupiter, we've got the Sun, we've got Mercury, and we've got Saturn, with more to rise soon, obscured by the daylight. Let's talk about Galaxy 3C279, which is a quasar. And the reason we're talking about this is because this is an optically violent quasar, which Robitaille talks about in the video that we referred to earlier. 3C279 is used as a calibration tool to calibrate the focus of telescopes and so on. So perhaps read about 3C279 if you're not already overloaded with cosmology stuff. If you want to follow the transients, we've looked those up. You can follow those on the Swift Bat Observatory, the Burst Alert Telescope, otherwise known as the Neil Gorell Swift Observatory. There are the transients. And again, we linked to that specific object as well as the Neil Gorell Swift Observatory monitor page. And we will bring the whiteboard back soon. We're not sharing the we're not sharing the URL for that yet, folks. So we will invite you to come and do graffiti on our now relatively weak whiteboard. If you haven't checked out smAshomAsh.org, it's brand new. Check it out. Scroll down, click on the link, go to the forum. We talk about all kinds of stuff from geophysics to cosmology to the sun. And we try to keep them all separate. And there's even an Alzheimer's disease discussion going on right now. We talk about X3. There's an image of it, by the way. That's a composite, including the X-ray as well as radio images. We also talk about things like the Earth's magnetic field. How is it generated? If you've got ideas, come talk about it on the smAshomAsh.com/forum. Also, thanks to our YouTube viewers. We do appreciate the support. Look for a lot of new stuff and different changes and all kinds of new features and stuff coming from the channel in the coming year 2020, where we make everybody's vision just perfect. And if you haven't viewed the video live on Twitch, well, that's where the video currently is live. And if you're not viewing it on twitch.tv/smAshomAsh, you're seeing syndication. But hey, that's okay. We don't mind. Thanks to our patrons. Expect to be on a credit crawl soon, probably this month. And thanks for being associate producers of the show. Thanks, Smash Team. That is everybody who views, leave comments, etc. Don't forget to share in your social media, as we are on the ground level of doing a lot of things. Stay tuned for some bonus features. Join us as we bust entropy and look at the current magnetic field environment of the local yellow dwarf. I heard from another YouTube channel that this is actually a sunspot, and I wouldn't be surprised. Let's look at the visible image, or the intensitygram rather. And there's the current image on intensitygram, and I do believe I see some ombre associated with that. It's official, that is a sunspot. So cycle 24 sunspot coming in. We're not quite at cycle 26 yet, folks. And I'm not seeing 2755. It looks like that one has evaporated. Let's check the date stamps. There you go. I don't see any dark umbral cores, do you? Except associated with this new rising sunspot. Cycle 24, polarity and location right on the equator there. Sunspot 2756, apparently. And here's the view in 171 angstroms. There's 2755 now, apparently decayed to a plage. And there is 2756. It's not looking super big, but we'll get a better view of the fields as it rotates into the Earth-facing region. Let's look at the 193 angstroms 48-hour video here and close things out. And we are out of here. We will see you soon, folks. Don't forget to stare at the sun. And click the links in the description below the video.